welcome you all. So कैसे हो सभी लोग? Hope all of you are doing great and all. You guys, welcome you all. So first of all, so please check this my audio video. Is the audio video is clear or not, everybody? So check this thing here. Is my audio and video quality is clear? Tell me everybody. Done? Fine. Chalo. Am I audible to all of you? Chalo. So let's welcome all of you. Welcome to this Unacademy. Welcome to the Kreatryx channel. So let's have one great information about this, the new initiative of this Unacademy. So we are starting the new batches. You can see the top educators of India. You can available here. You can find the top educators of India is available here. We are starting the new batches from the December 21st onwards. You can have a look at here. And for the GATE 2024, we are starting the new batches. Have a look at here. Now these are the batches you see, and GATE 2024 and 2025. You can find the top educators team. You can find here. Next. And these are the USPs of these batches here. You can find the comprehensive syllabus coverage and the access to all the GATE digital notebooks. And so this is 8,500 plus books are there, plus pages are there, and so nearly more than 5,000 plus DPP questions, daily doubt solving classes we have, practice session and test series and all. So with a single package you can get everything. And this is for the Udaan batch for 2024. You can find the top educators team. You can see, and these are the new batches. You can see have here, right? Now you see this thing here. These are the new batches you are starting. You can follow this thing, and there is a huge announcement here. All of you, there is chance to get 52% discount. There is chance to get 52% discount, and so there is a huge discount is this offer which is applicable only up to the December 16th only, and try to utilize this opportunity as soon as possible by using a code of BV Reddy. And once you have used the code of BV Reddy, you will be completely under my guidance. You will be completely under my guidance. Will take care of your complete preparations, right? Next, these are, as you might see, recently seen the IRMS new announcement. So for this we are starting the new batches. We are starting for IRMS, and our IRMS mains we are starting the new batches. You can see, fine. And you in these batches you can able to save up to the 39%. You can able to save it for IRMS batches and all. So you can plan your Unacademy subscription as soon as possible, and you can use a code of BV Reddy to get the personalized guidance and personalized discussion with me. Fine. And so as you know here, so to know the mistakes where you are committing your mistakes and all, so for that purpose you need to attempt the number of tests. And so we are providing the all India mock test, and so total 6 mock tests we are providing before this GATE. And this mock test, all these mock tests are completely free of cost. You can access this mock test. Fine, all of you. With this mock test you will get to know where you are committing the mistake, what are the mistakes, and where you need to rectify. You will get to know. Fine. Last we have seen some topics we have discussed now, all of you. About the electric dipole हमने discuss किया. All of you बोलिए. About the electric dipole we have discussed. Right. If you have any doubts in the previous classes, let me know. Let's have a discussion about this. Let us have the discussion if you have any queries and all. So here till now we didn't reach that concept. So here as of now here that is separate here. So here am I told the syllabus completed? Am I told the syllabus completed? So here syllabus आएगा ना. So we are not reached to that concept. So here you can see the title of the heading, you can see now. You can see that for the first, you can see the heading, you can see what we are discussing. So according to that we are discussing, isn't it? According to the title we are discussing the topics in a one by one. If I say the syllabus is completed, then you should ask, so this topic is not covered at all. So we are doing the syllabus, we are doing now, then how we can say it is completed? How we can say this topic is not covered? I'm covering this thing. So here I have my sequence. I used to follow some sequence. I used to follow. In that sequence only I will discuss now. Randomly we cannot follow. So here one by one. So here we have, with our experience, we know which topic has to be covered, which topic has to be covered in the sequence manner, right? Fine. Last we have covered the, this is electric dipole हमने discuss किया. Tell me all of you. इलेक्ट्रिक डाइपोल हमने डिस्कस किया. नाउ लेट्स discuss some problems and we'll move to the next topic. Take this problem here, and we have seen what happens when the charge is dipole is placed in the uniform electric field. Now take this problem. If a charge q is separated by distance of r from the center of the electric dipole, then find the force between them. Generally we used to find the force between the two charges. Now here they are asking to find the force between the one charge and one electric dipole. Yes, I have a charge q here and we have one dipole is there. Let us consider here this is a dipole. Consider this is one negative charge I am considering here, and this is the positive charge I am considering here. This is the electric dipole. And this dipole means it should be separated by a small distance now here, and this distance I am calling this thing as something d. Okay, this distance, for easy understanding purpose, we have taken this thing as a L. This I am taking this as a 2L. That means this is the midpoint of the dipole now. That is a midpoint of the dipole. Now I want to find the force between the this charge q and the electric dipole. Fine. Now you see this thing here. Let us find the force between the each charge. Now I can say here this distance यहाँ से यहाँ तक. If I call this distance as something r, if I say, can you tell me the force between the positive charge and electric dipole? Can you tell me the force between these positive charge and electric dipole? Which is given as what now? Positive charge and negative charge. Let us find. Which is given as, tell me now here, kq, and then here which is equal to positive charge. So here you tell me now here this distance, and 1 second, what is this r is given, कहाँ से कहा था कि given here from the charge to the where r is given to where, you tell me now here up to here. This is given as a r na. This is given as a r, isn't it? From r's center, that's why it is a r. Now you tell me now here, if I ask the here what the distance now here from the positive charge, now here tell me kq by what I can say, this is now this distance is r plus l whole square. हाँ ना बोलिए this thing. Is it fine? Is it fine, all of you tell me? Next, and what is the force between this positive charge and negative charge, you tell me? Which is given as, that is minus kqq by what I am saying here, that is r minus l whole square. बोलिए this thing, everybody. Now let's simplify this thing, that's nothing else. इसके बाद just simplify करो. So then we will get the force, we can get it now here. Tell me all of you. So ये r plus l, r minus l आपको समझ में आया? Right. So this distance is what, you tell me now, L na, and this distance is another L. Is it fine, all of you? Then let's simplify and get it. Now simplify this force now here, and what I can say now here, K Q we have taken common, and then what else I can say here, that is 1 by, this is R plus L whole square minus 1 by R minus L whole square. Simplify this thing, R plus L whole square and R minus L whole square. Next, so then simplify this expression here, KQQ into what I will get now, this is R minus L whole square minus of R plus L whole square by, so this I will get A plus B into A minus B form now, so it is in the form of R square minus L square whole square. Check this thing all of you, which is nothing but R square minus L square whole square. Check this thing. So now let's simplify these expressions. क्या आएगा, tell me. Let's simplify the expression here. Now tell me now, KQQ into what we'll get now here, it is, so this is the form of what we can say, A minus B whole square minus A plus B whole square. So अगर simplify किया तो क्या आएगा, tell me इधर now here, which will get this thing as a minus 4AB will come now, 4RL by, so here denominator if you see carefully now here, and what is the L is a, where what is the L is a, L is the dipole distance. Now if you see carefully, so this dipole distance L is very small compared to R. This L is very small compared to R. Now tell me, then L square is even less than R square. हाँ ना बोलिए, इसीलिए we are nullifying this thing here. I can approximate this thing as simply R power 4. Tell me, I am simply approximating this as a R power 4. So tell me now force, which I can write this thing as finally, that is KQQ minus, here what I will get now here, 4L by RQ. 1 R will get cancelled, 1 R will get cancelled. So now this force which I am modifying this thing as, that is minus of 2KQ. KQ, I am writing this thing as 2K, right, 2K into what I am saying here, this is 2L into Q by RQ. Hana boliye this thing. So from this force which is given us, that is minus 2K into, so if you see carefully, now you see this thing here, this is Q into 2L, that means what now, charge into this length, which is now called as a dipole moment. Now tell me, which is called as a dipole moment, so which we can call this as a P, I can say P by, I can say this as RQ. So finally the force between the charge and the dipole, which is given as minus 2K PQ by RQ. Hana boliye this thing. Done. This is the force between the charge and the dipole. Now this formula, so we have derived this formula, we are converting into very much easily. So here you see this thing, look at now what I did. Here I have taken one charge Q, I have taken some charge Q, I have taken. Here we have taken one dipole, we have taken P and this Q, and this distance which we have taken this as a 2L. Now you see this thing here, this is my dipole. Hana boliye, This is what now here? This is a dipole. Now this dipole means it has a, you should treat, it has a some dipole moment. The dipole moment of this thing is what you tell me now here? P. Now, so what I am saying is, now you just see this thing here. This is my Q. The whole thing I am treating this as a dipole, as simply one point I am treating, having a dipole moment is P. The whole thing I am treating this thing as a single point having a dipole moment is what you tell me? P I am taking. Okay. Now you see this thing here. Now I am seeing this thing. Can you, this distance from the charge to this center of the dipole is a r na? Now can you find the electric field at this point P because of this charge Q? Because of this charge Q, can I find the electric field at the dipole moment, at the dipole? That electric field which is given as what I can say here, kq by r square. All of you boliye, which is given as kq by r square. Now can you tell me what is this thing here, dE by dr? If I differentiate it now, what I will get? Differentiate this electric field with respect to r distance, what I will get? That is minus 2kq by r cube will come now. Minus 2kq by r cube will come. Now so here this is the electric field. Now I need the force now here. I need the force F, which is given as, you can see this thing here. This is minus 2kq by r cube into this dipole moment P. I can multiply, tell me. Boliye this thing. Can I modify this formula now here? Tell me, can I modify this thing here, which is given as, now this is given as a dipole moment into, tell me what I can write. So this is dE by dr. Boliye this thing. This is the force between the charge and the dipole. Can I modify this formula as like this? So अगर आपने ध्यान से देखा तो see this thing how we are approaching now. So whenever you need to find force on a dipole, what we should do here? So dipole whole thing treat as single point, that is at the center point. Then find the electric field at the center of the dipole because of the charge Q. Find the electric field at the center of the dipole because of the charge Q, and differentiate the electric field with respect to distance, and then dE by dr into its a dipole moment will use the simply the force. Is it fine, all of you? Then now you can see. Now take this problem and tell me. A infinite line charge Royal coulombs per meter is placed at a distance of r from the center of the dipole. From the center of the dipole. Then force between them is. Then the force between them is. I have an infinite line charge. This is my infinite line charge having a charge density Royal coulombs per meters. Having the charge density Royal coulombs per meters. Now, so here what I did now here. So here a place now here they are saying that they are placed at a distance of r. At this location we have a dipole is placed. How much this distance, you see this thing here? This distance is r. A dipole is placed at a distance of r. Now this is a point. Now here having a dipole moment, let us call this as something P, where what is the P is a dipole moment. P is a dipole moment. Now what I need to do here, tell me. So I need to find the force. Now what I should do here? First, because of this line charge, due to this line charge, let us find the electric field at the point P. Due to the line charge, let us find the electric field at the point P. Tell me now here, what is the electric field at the point P because of this line charge? It is an infinite line charge now. The electric field at the dipole, which is given as, that is rho L by, tell me, 2 pi epsilon into r now, where r is a perpendicular distance, rho L by 2 pi epsilon into r, isn't it? This is the electric field. Now what I need to do here, tell me? I need to differentiate this electric field with respect to distance, that is dE by dr. Tell me, if I differentiate, then what I will get here? That is equal to, this is minus rho L by what? And this is 2 pi epsilon into r square now. Now what is a force, you tell me? Force is equal to, that is P into dE by dt, P into dE by dr. So which is given as, what I can say now, P is the dipole moment, which is given as minus P into, this is rho L by 2 pi epsilon into r square. Tell me this thing. This is the force. Is it fine? Done. Next, take the next problem. An electric field on a plane is described by its potential as like this. E is equal to 20. Yes, the potential which is given as what? That is 20 into, they given this as 1 by r plus 1 by r square. They given the potential as like this, where r is a distance. Now this field, they are asking here, then this is because of what? Then this is because of what? You see this thing here, we have the potential is 1 by r. If we have potential is 1 by r, that potential is because of what, tell me? So in case of a monopole, single charge, potential is proportional to 1 by r. So that means here we should have a monopole. Now tell me, this 1 by r proportionality is because of this monopole. And here we have 1 by r square. 1 by r square means that is the potential due to the dipole. This is the potential due to the dipole now here. That means here we have a combination of both, and monopole and dipole is there. That means here we have both monopole and dipoles are there. So this field is because of what, you tell me? It's a combination of monopole and dipole. This is the combination of both monopole and the dipole. Fine, all of you? Right. Then everybody completed? Next. Next one. Poisson's equations. Next one, Poisson's equations. Now see the things now here. So as we know the Maxwell's first equations. What is Maxwell's first equation we have? Del dot D, which is equal to rho V. Del dot D equal to rho V. And we know that D equal to epsilon E. D equal to epsilon E. So here, now from this, what I can do here, D, and we can replace now here. If I replace this thing here, we'll get the D is equal to what you tell me now here. Now D into, which we can say this as epsilon E, which is equal to rho V. बोलिए Jahar. What is Jahar, yeah? Jahar. What is the Jahar? Now epsilon. If the epsilon is a constant, now here what I can do here, if epsilon independent of space, if epsilon is independent of space, independent of space means it should be a constant. Space means x, y, z. If it is independent of space, then I can take out outside now. Then we can take outside here. Then this is epsilon into del dot E, which is equal to rho V. Now from this, what I will get now here, what is my del dot E? So del dot E, which is equal to rho V by epsilon. Del dot E, which is equal to rho V by epsilon. Now we know the relationship between and the potential. What is the relationship between electric field and potential? That is E equal to minus del V. E equal to what? Minus del V. E equal to minus del V. Now tell me now what we can do here. I can replace here. Here, so this is del dot of E is equal to minus del V, and which is equal to what I can say here, rho V by epsilon. Now tell me now here, this is, I can say del dot del, which is equal to del square. Now tell me, so that is del square V, which is equal to minus rho V by epsilon. Del square V equal to what you tell me, minus rho V by epsilon. This is the equations. Now this equation, which is called as a Poisson's equations. This equation is called as a Poisson's equation. This equation is called as a Poisson's equations. Okay. Right. Now let's have a look at here. All of it ध्यान दो इधर. Here, to get this equation, how we have approached, you tell me. And here we have started this equation, right? This is one equation 1. Here I have used this equation, these relations, and second one. And I used this equation here. Yes or no? Now this is a third equation. Now अगर आपने ध्यान से देखा तो मैंने क्या किया इधर? What I did to get this equation, you tell me. अगर आपने ध्यान से देखा तो you see this thing here, what I did to get these equations. मैंने क्या किया, tell me now इधर. If you simply know these three equations, from this you will get the fourth max Poisson's equation. मिलेगा कि नहीं बोला आपको? So I have combined these three equations. By combining these three equations, मुझे, so we got one new equations. ये तीन इक्वेशन को मैंने कंबाइन किया. कंबाइन करने के बाद सो वी गॉट द न्यू इक्वेशन आया. मुझे एक नया इक्वेशन आया. दैट नया इक्वेशन को क्या नाम दिया मैंने? दैट नया इक्वेशन को क्या नाम दिया हमने? पॉइजन्स इक्वेशन का नाम दिया. अगर आपने ध्यान से देखा तो इस सारा थिंग्स में जो हमने किया, इसमें टेल मी नाउ व्हाट द पॉइजन डिड हियर. What the Poisson did here, you tell me. Poisson ने क्या किया इधर? पॉइजन ने क्या किया इधर? तो उन्होंने सिंपली एक दो तीन इस तीन इक्वेशन ले लिया, ये तीन इक्वेशन को सब्स्टिट्यूट करके सो हियर इन्होंने कुछ नया इक्वेशन बनाया. So that new equation he named as a Poisson's equation. What he did, you tell me now here. So apart from this naming as a Poisson's equation, is this fellow did anything? Apart from naming this as a Poisson's equation, you tell me, yes, will the Poisson did anything here? So he has taken this equation and this equation. He combined the three equation. उनको कुछ नया equation मिला. So ये equation को he has seen this thing here. So see this thing here. So here you tell me now how great the Poisson is. You see this thing, how great the Poisson is. And you might heard about the great scientist and all. Yes, see this thing, how great the Poisson ने क्या किया? I told you now there are so many smart fellows in our subject. So here previously we have seen about the fellow Maxwell. Yes or no? Maxwell के बारे में हमने डिस्कस किया how smart these fellows are. He is another smart fellow. He is another smart fellow, Poisson's. Right? Now you see this thing we got. Yes, exactly. So here now we got the Poisson's equation, right? We got the Poisson's equation. Now अगर आपने ध्यान से देखा तो here, so here we got the Poisson's equation. अगर आपने ध्यान से देखा तो here, if rho v equal to 0, if rho v equal to 0, then what happened to this equation, you tell me? What happened to this equation, you tell me? Then it will become del square v, which is equal to 0 होगा ना? Del square v, which will become 0 ना, बोलिए. So here इसका नाम, so this is called as a Laplace equation. This is called as a Laplace equation. This is called as a Laplace equation. अभी बोलिए now here, who is great? अभी बोलिए who is great? Poisson's or Laplace? अभी बोलिए. So who is great fellow here? Poisson's is great or Laplace is great? If we say Poisson is great, then the Laplace is greatest na? If we say Poisson is a great fellow, then you can talk about the Laplace. How great this Laplace is. Isn't it? Right. How great the Laplace is. So here आपको ये idea आपको नहीं आया, I think शायद. So I think so you don't know the logic. You know Poisson and Laplace has a patent on these equations. You know Poisson has a patent on this equation. Laplace also has a patent on this equation. You know, right? Now you tell me now here. So I think शायद ये टेक्निक आपको पता नहीं होगा. So I think so here ये टेक्निक आपको पता नहीं होगा, इसीलिए अभी तक आपका नाम पर कोई पेटेंट नहीं है. So here इसीलिए आपको so कोई पेटेंट नहीं ना, ये टेक्निक अभी पता चला नहीं आपको. So then now you also you can try for one patent. So by combining some equations आपको कुछ नया इक्वेशन मिलेगा and apply for patent. Okay, so बहुत बढ़िया होगा ना, isn't it? Now, so अभी तक हमने क्या किया? अभी तक हमने इसको ये फेलोज का स्मार्टनेस हमने देखा. Now you are going to see the greatness of these fellows. अभी हमने इसका स्मार्टनेस हमने देखा. लेट्स टॉक अबाउट द ग्रेटनेस ऑफ दिस फेलोज. देखो इधर, अभी तक हमने सो वी हैव सीन द इलेक्ट्रिक फील्ड फॉर्मूलाज फॉर डिफरेंट टाइप ऑफ चार्जेस हमने देखा ना. Electric field because of the different type of charges k cube by r square for the point charges, and for line charges which we have seen this as, so for line charges we have seen and which is given as infinite line charge rho l by 2 pi epsilon rho, and for surface charges we have seen that is rho s by 2 epsilon, and for volume charges we have seen that is r rho v by 3 epsilon inside, outside is r cube rho v by 3 epsilon into r square. So ये सारा हमने डिस्कस किया अभी तक. अगर आपने ध्यान से देखा तो हियर टू फाइंड द इलेक्ट्रिक फील्ड फॉर डिफरेंट टाइप ऑफ चार्जेस, टू फाइंड द इलेक्ट्रिक फील्ड हमको क्या क्या चाहिए. So we know the k value, k is a 1 by 4 pi epsilon, we know this value, and then r is a distance भी हमको नहीं पता ना. So here what else are things we should know to find the electric field, you tell me. What else other things we require to find the electric field, you tell me. And we should know the charge, we should know ना. We know the charge. अभी तक हमने देखा, so I have simply given a 1 coulomb of charge. So here 10 nanocoulombs of charge, 100 microcoulombs of charge, like this we are talking here. We are talking this type of charges we are talking. But लेकिन इसका problem क्या है? We don't have any equipment to measure the charge. But लेकिन इसका problem क्या है? So we don't have any proper equipment to measure the amount of charge. ये चार्ज मेजर करने के लिए हमारे पास कोई डिवाइस नहीं है. Okay. So here then what happens now, without having any charge device we cannot measure the charges. हाँ ना बोलिए. So then if you see carefully, all these formulas are based upon if I know the charge, then only I can do. Without knowing the charge, can I able to find the electric field? ये तो possible भी नहीं ना. It is impossible. It is not possible ना here. So that's a problem. So that's why we need to go for some alternative method is required ना. So we need to go for this alternative method. अभी तक हमने जो डिस्कस किया ये सारा एनालिसिस only the theoretical analysis के चलेगा. But practically this is not at all possible. All these things whatever we have discussed, provided if I know the charge. But we don't have any device to measure the charges. Fine. So now we are going to see this thing here. What we are going to do, how to rectify these things and all we are going to see. We don't have any device to measure the charge. No device. But we have a device to measure the potential. But we have a device to measure the potential. Hana boliye. We don't have any device to measure the charge, but we have a device to measure the potential or the voltage. अगर आपने ध्यान से देखा तो if I know the potential V, by knowing the potential V, can I find the electric field? Can I find the electric field if I know the potential? So by using the relation of E is equal to minus del V, all of you, by using this relation we can get the electric field. If I know the electric field, I can get the D, we can get not, D is given as epsilon E, D is given as epsilon E. If I know this thing here D, I can get the flux now here. Flux is given as surface integral of d dot ds, Gauss law. As we know charge Q which is equal to flux now, tell me. अभी बोलिए इधर क्या होगा, you tell me. Now by knowing the potential, I can get electric field, E, D, flux and charge. All these things are possible or not? So this is the method we are going to approach practically. This is the method we are going to approach practically. Fine. Now, if we see this thing, what we can able to do here? We have a device to measure the potential, but we cannot measure the potential at each and every point. What we are going to do here, let us consider here what we will do here now. So like we might see this type of technique in your mathematics. For example, they has given some function they given. In your maths, you might study this type of scenarios. They given the some mass sum. Let us consider we have given. Yes. So आप डिस्कवर करने के लिए कोशिश करो. So you try this thing. Why don't you try? Why the some other fellows has to do, yeah? So आप try करो. Why can't you? So you try this thing, yeah? Isn't it, Rakesh? आप try करो. Why we need to follow others, yeah? So आपने कुछ रास्ता दिखाना पड़ेगा. Okay? आप try करो. या आपका नाम भी हिस्ट्री में लिखेगा. सो हियर आपका भी कुछ नया आएगा. राकेश इक्वेशन ऐसा नाम आएगा. Right. Now you might study the things now here in your maths. The things you might studied means what you tell me now here. And let us consider I have some function is there. Let us consider we have some function. See some function we have. This is one function we have, but capacitance is required now. But capacitance is required or not? Capacitance भी पहले find out करना पड़ेगा. But so to use this thing, Q is equal to CV, but C value required ना. But C value तो C value Q depends upon Q, Right. Even we don't have any equipment to measure the capacitance also. Right. So here you see this thing here. Look at now here. Allah सुनिए. So here the practical orientation बाद में. So here once after you fellows are entered into IITs, आप सोचिए. So then how you need to do this thing here. But अभी तो here आपने पूरा so here exam के बारे में सोचना पड़ेगा. So after entering the IITs, you have a lot of time you can think about this thing. We are nearby very exams ना. So इसीलिए हमने focus करना पड़ेगा exam पर focus करना पड़ेगा अभी. Look at now here. So I'm measuring so we cannot possible to measure the potential at each and every locations. इसीलिए मैंने कुछ random points पर select किया. A random point, let us say x is equal to a, we have measured the potential something here. X of a we are calling. This is the potential at this point. And if I call this point is something b, and this I'm calling this thing as a f of b I'm calling. By knowing the potential at the 2 points, let us say here at x is equal to a and at x is equal to b, by knowing the potential at the 2 points, if I can able to form one function, by knowing this thing, if I can able to form one function, if I formed, then what happens, you tell me? If I can able to form one function, then see what's going to happen, you tell me. With this, if I can able to form one function, now tell me now, can I say that, so here we can able to do the values of the function at each and every location, some other location also possible to find or not? Here, anywhere we can able to find. Yes, this type of problems even you might see in your maths also. In the mathematics you might study the things now here. They will given some differential equation, let us say dy by dx plus something ky which is equal to 0. And they will give something y of 0 which is equal to something they will give. They will ask to find the y of 10. ऐसा type of problem आपने देखा क्या maths में? Isn't it? They will give something value, they will give this as a 2, they will ask to find the value of y of 10. This type of problem you might seen in the maths also now. What we used to call this type of problems here? This type of problems are called as what? You tell me. Initial value problems. आपने सुना होगा. This type of problems are called as what? Initial value problems. These initial value problems are also called as a these initial value problems, and we have other name. We have this type of problems are called as a boundary value problems. Have you heard this word? This type of problems are called as a boundary value problems. This type of problems are called as a boundary value problem. Have you heard this word? Right. And to get the solution for this equation, first of all, we should know the differential equation is required or not. We require the differential equation. Yes or no? Those differential equation is nothing but the Poisson's and Laplace equations. Those differential equations is nothing but the Poisson's and Laplace equations. So this Poisson's and Laplace ने इतना सारा किया, पॉइजन्स और लैप्लास ने इतना वर्क किया, इसीलिए उनका नाम पर पेटेंट मिला. अगर आप सिंपली एक इक्वेशन डेराइव किया तो आपको पेटेंट नहीं मिलेगा. So here you need to explain what is the significance of those equations. Where the regular methods are not applicable, where your method is valid, you need to explain. तभी आपको पेटेंट मिलेगा. सो इसीलिए तो इस साइंटिस्ट को कभी भी अंडर एस्टिमेट मत करो. ओके, but just for fun we used to talk, but the thing is all these scientists are really great fellows. Okay, right. So this is the equation now here. To get the solutions, now we use a Poisson's equation or Laplace equation we use. Yes, del square V, which is equal to what we can tell me now here, minus rho V by epsilon. This is a Poisson's equation. In the problems, if they given the rho V value, consider. So if there is not mentioned, so let us assume the rho V value 0. If the rho V value 0, then we use the Laplace equations. If the rho V value 0, then we can use a Laplace equation. If the rho V value non-zero, Poisson's equation. Rho V 0, we will go for the Laplace equations. Fine. Now let us see this del square operation. Del square operation the different coordinate systems. So del square V operation in the different coordinate systems. So del square V is equal to, is given as dou by dou x of dou V by dou x plus dou by dou y of dou V by dou y plus dou by dou z of dou V by dou z, which is equal to minus rho V by epsilon. Check it all of you. This is the Laplace Poisson's equation in case of what system? Cartesian system. Now let us talk about the cylindrical system. Cylindrical and spherical system, these are little different, so try to remember. Which is given as 1 by rho into dou by dou rho of rho into dou V by dou rho. Okay, next 1 by rho square into dou square V by dou phi square plus dou square V by dou z square, which is equal to minus rho V by epsilon. And spherical system, del square V, which is equal to 1 by r square into dou by dou r of r square into dou V by dou r. plus 1 by r squared sine theta into dou by dou theta of sine theta into dou v by dou theta plus 1 by r squared sine squared theta into dou square v by dou phi square, which is equal to minus rho v by epsilon. Okay. Done all of you? This thing. So these are the cylindrical, Cartesian, spherical systems. Now, is it easy to remember or not? Will you remember this thing? Right. Now see this thing here, mostly for electrical guys, only the first equations here will possible. So here only for this is electrical guys can able to remember this thing. Yes, only for this thing. So here we can do this thing. Right. So here, and this is Cartesian system is easy to remember or not? Cartesian system is easy to remember. Right. Easy to remember. Now we can easily remember this thing. So this thing you can do remember. Now coming to the cylindrical and spherical system. Coming to the cylindrical and spherical system. So here mostly here try to remember this thing, cylindrical system you try to remember this thing, and spherical system you try to remember this thing. Mostly 99% of the problems are based upon this thing. For this mostly any of the objective type of exams, if we remember this thing, that is sufficient. So for any of the objective type of exam, that is sufficient. And but if you are preparing for conventional type of exams, full equation is required. Right now you are focusing on this GATE and ESE for objective type of exams now. So better, so you can plan to remember this, with this is sufficient. This thing and this thing you can remember easily. Okay, and done. Chalo. So that Laplace equation we have discussed now. Right. Take one problem. Take one problem. The potential distribution is given as V is equal to 10 into y power 4 plus 20 into x cube. If epsilon naught is a permittivity, the charge density they are asking to find. Epsilon naught is a permittivity they are asking to find the charge density. Means the volume charge density. Right. Tell me now here. We know the Poisson's equations. From the Poisson's equation, that is del square V, which is equal to minus rho V by epsilon. Tell me. Epsilon is given as a epsilon naught. Epsilon is given as what you tell me? Epsilon naught. And what system I have to use, you tell me? क्या system I have to use, you tell me now here? What system I have to use, you tell me now here? They given the potential is what system they given? Cartesian system they has given. So we use to the Cartesian coordinate system we use. Okay. Now use up the del square in the Cartesian system. Tell me what we can say here. That is dou by dou x of dou v by dou x plus dou by dou y of dou v by dou y plus dou by dou z of dou v by dou z, which is equal to what you tell me? Minus rho v by epsilon. Epsilon is a epsilon naught. Now you tell me now here dou by dou x of dou v by dou x. I have to differentiate the potential with respect to what you tell me. This whole equation I need to differentiate with respect to x. X derivative what I will get, you tell me. So then this is 60 x square plus next y derivative, now tell me what I will get now here, 40 y cube, and the z derivative to 0, now tell me, that is minus rho v by epsilon naught. बोलिए. Now again differentiation, what I will get now here, 120 x square. Next what we can say now here, 120 y square. So this is 120 x now derivatives, and this is 120 y square, which is equal to minus rho v by epsilon naught. Now simplify this thing. So from this what I will get now here, rho v, which is equal to minus epsilon naught into what we have, tell me, 120x plus 120 y square. Now they are asking to find rho v at a given point. What is the point is given, you tell me now here, 2, 0. So then what I can say, x value 2, so it will becomes minus 240 epsilon naught hoga na, that is minus 240 epsilon naught. Is it fine? And done. Next one. Take the next problem. The three values of a one-dimensional potential function phi shown in the figure, okay, satisfy the Laplace equations are related as. Now what they are saying here, you tell me what they are saying here. This is a one-dimensional potential function satisfying the Laplace equations. Now this means if you have considered this point, if I call this as x is equal to 0, at x is equal to 0, if I say x-axis, now at this x is equal to 0, at this point we have potential is phi 1. At this point what I should call now, this is x is equal to d. This I will call this as a x is equal to d. How much the potential, you tell me? Potential which is equal to phi 2. Now at this location what is the x? Tell me at this location. X is equal to what, you tell me now? 3d na? At 3d, so tell me now kya hoga? At 3d what happens now? Potential which is equal to tell me now here at this location phi 3. Hana boliye, this point understood? The given data. Now they are saying the one dimensional Laplace equation. What is the Laplace equation? Tell me first of all. Del square V which is equal to 0. This is the Laplace equation. Now tell me. This is a Laplace equation, right? Now they are saying it is what now here? One dimensional analysis. Let us call this as a x, y, z. Let us consider only one dimension, that is x direction. So what I can write now, tell me x direction, that is dou square v by dou x square, I can say. Now tell me, which is equal to 0 I am considering. Hana boliye. Why? Because they are talking about one dimensional ना here, इसीलिए मैंने एक x dimension x consideration we have taken. They are saying it as a one dimensional equations. all of you बोलिए. So here dou square v by dou x square equal to 0. Now tell me, if I integrate one time, that means dou v by dou x. If I integrate one time, we'll get this thing as dou v by dou x, which is equal to, we can say, constant c1. Dou v by dou x, which is equal to constant c1, will come now integration on both sides. Next, if I do again integration, so what I will get, to tell me. So v is equal to, which will get this as c1 into x plus some other one more constant will come now, c2 va. Will get the another constant c2 will come. Now this is the potential value. V is given as c1x plus c2. V is given as c1x plus c2. Now these c1 c2 are the constants, and how we can get the constant? By the initial condition or the boundary conditions. By initial condition or boundary conditions. Tell me now what they given now here. At x is equal to 0, so how much the potential they given as a I1 given. Hana boliye. Let's move the next page. So we got the potential function V, which is given as a C1x plus C2. What they given the potential condition now here? At x is equal to 0, how much the potential is given? You tell me. V value, which is given as a 5.1. And at x is equal to D, what is the potential V value? Tell me, given as a, which is equal to 5.2. Now tell me now, at x is equal to 3D, how much the potential they given? You tell me, which is equal to 5.3. Boliye. Now can I substitute these values in the above equations? So substitute now here. If x is equal to 0, if I substitute, then tell me what I will get the values now here. Potential, which is equal to 5.1, which is equal to, we'll get the c1 into x value 0 plus c2. So from this thing we can say that c2 value, which is equal to 5.1 na? C2 value 5.1. Let's place a second condition now here. V value, which is equal to 5.2, which is equal to, that is c1 into d plus c2, which we got this as a 5.1 we got now. So from this c1, which is given as 5.2 minus 5.1, 5.2 minus 5.1 into d. Tell me all of you. Now by knowing these two values, I can substitute the above equation now here. Then V, which is given as C1, which is given as, what you tell me now here, 5.2 minus 5.1 by D, 5.2 minus 5.1 by D into X plus C2 value. How much the C2 value? Tell me, which is equal to 5.1. Ha na boliye. We got this thing. Everybody tell me. Now, so they are given some options they given. So see the options now here. Which are the following equation satisfies? Correct options. Now what I do here, x is equal to 3, the phi is potential is given as a phi is given. Can I substitute this condition also? That means phi 3, which is equal to, what I can say here, phi 2 minus phi 1 by d phi 2 minus phi 1 by d into x. What is this x value? Tell me now here, which is equal to 3d plus phi 1 plus phi 1, and simplify this thing here. You can see what I will get the relations. कौन सा ऑप्शन satisfy होगा आप ही बोलिए. So finally, so we'll get this phi 3. Finally, we'll get this as what you tell me, phi 3, which is equal to what we can say now here, phi 2 minus phi 1 into 3 plus phi 1. Tell me, let's multiply and simplify this thing. So what we'll get now here by simplifications here, this phi 3, which is equal to 3 phi 2 minus 3 phi 1 plus phi 1. So tell me what I will get now, phi 3, which is equal to 3 phi 2 minus 2 phi 1. So that means options में क्या आया? All the cases phi 2 they has given. So can I find the phi 2 from this equation? So phi 2, which is given as what I can say here, phi 3 plus 2 phi 1 by 3. Now check the option. Now check the option. Which option will satisfy this relation? कौन सा ऑप्शन होगा? टेल मी. 2 phi 1 plus phi 3 by 3. So option B, tell me. Option B satisfy होगा. Then yes. Completed all of you, tell me. Yeah, you might seen the some किसी ने आया. So here he is asking to, so here both come students are, he is asking to close. So बंद करने के लिए बोला. Shall we बंद करेगा classes? Shall we stop the classes? You tell me. किसी ने बोला ना. So here somebody came to the classes and he is saying that, so here, so very less students are there. He asked him to, so why you are taking the classes? So he asked him to close the classes. So shall we बंद करें? Shall we close the classes? You tell me. I'm asking here. So here, and if we could have this thing here. So here, so आप ही ने सो कुछ करना पड़ेगा ना. So here आप ही ने कुछ उनको comment देना पड़ेगा. So here you fellows should comment on that fellow. So तभी so here then so उनका मुंह बंद करना पड़ेगा. तभी उनको भी so here ऐसा मत बोलेगा ना. So I am teaching for you fellows. So you have to support the things ना. The initiative what we are doing here. So ये किसके लिए करने वाला हम लोग. So here I am teaching this thing for myself or for आपके लिए. You tell me. Basically I used to take the plus classes only. So this is the first time I'm coming to this channel, and first time I'm teaching the YouTube. So this is the first time I'm coming to the YouTube classes. You remember? Okay, so here पहली बार मैंने आया YouTube पर. So previously, so here you can see I have been teaching in this Unacademy from 4 years onwards. So all my classes available in the plus classes. You can see plus classes you will find. So आप ही ने उनको काउंटर देना पड़ेगा ना. आप उनको काउंटर देना पड़ेगा, तभी ये मुंह बंद करके सो ये बाहर जाएगा. अगर आपने चुपचाप बैठा तो हियर क्या होगा? So here, so he will keep on will comment, isn't it? Fine. Okay then, that's for the today's sessions, and we'll meet tomorrow. And tomorrow we'll do the next concept. We'll do the method of images. Fine. Okay then. See you. Bye bye. Good night.